Assalamu alaikum everyone. This is Zainab again from DICE Analytics to welcome you all for the fifth round of DICE webinar series, Everything DevOps in Conversation with Ali Kahoot. As the title is quite self-explanatory, we are very glad to have Mr. Ali Kahoot as our speaker for today. Mr. Ali is currently working as a senior DevOps engineer at Tarabut Gateways and has been associated with DICE as DevOps trainer. He has been associated in this industry since more than 6 years with broad experience in software development and developing CICD workflows for complex applications consisting of different various microservices. He has been working on tools like Jenkins, Docker containers, Kubernetes, Helm for years. Today, he'll be discussing about what is actually DevOps, why one should move to DevOps, why DevOps is the highest paid job, its best practices, essential technologies which are required to move to DevOps, and will also be conducting a demo session of CICD with GitHub Actions on Kubernetes. Mr. Ali has mentored many students and professionals and helped them get ahead in their careers, so don't forget to note down your QBs and discuss them with our domain expert in the Q&A session at the end. Thank you so much everyone for joining us today. I hope we all get the most out of today's session. Over to Mr. Ali.
Hi Zainab, hi everyone. Let me share my screen. Are you able to see my screen, Zainab?
Ji sir, we are.
Sure. Okay. So hi everyone. Welcome again to the DevOps session, Everything DevOps. Today we will be discussing about different things about DevOps. Before starting, I will just introduce myself. My name is Muhammad Ali Kahoot. These are my social media handles. This is my LinkedIn and this is my GitHub account, so you can visit them if you want. I am currently working as a senior DevOps engineer at a Bahrainian-based fintech startup, Tarabut Gateway. So I am working over there as a senior DevOps engineer, and I am basically setting up the complete infrastructure and all of the DevOps cycle for that. I am also working as a part-time there is a question we can't hear properly. Can you hear me properly, everyone?
Now we can.
Okay, I think so. It will be the issue of the attendee. So basically, I am a part-time DevOps trainer as well at DICE Analytics. I have conducted almost 6 sessions of DevOps batch, 6 batches of DevOps for DICE Analytics. I am a DevOps consultant as well. I work freelance for some companies. I have previously led a team stakeator at Aurora Solutions. Basically, it was a Swedish-based startup which provided DevOps as a service solution. Okay, there is one person saying that there is some noise. Okay, is it better now? Can someone tell me in the comments?
Yes, it's better. We can hear you now.
Sure, thank you. Okay, so basically I have led a team stakeator in Aurora Solutions as well. Previously, I basically was a software engineer at Bentley Systems. I am certified in Kubernetes application developer and also certified in Red Hat delivery specialist, the OpenShift container platform. Other than that, I am an avid open source contributor. I have just a minute, close this, yeah. So I have a blog on Kubernetes with more than 97,000 views and 1.70 claps on Medium. I'm expecting it to be 100K in the next 1 week. So hoping for the best for that. I have trained more than 400 resources on DevOps and Kubernetes globally, even in Pakistan as well as outside the world. I have been a public speaker. I have spoken at S&P DevOps Week on data on Kubernetes community, and also conducted more than 10 boot camps on Kubernetes. My technical expertise include, but not limited to, Git, containers, Kubernetes, OpenShift, Helm, Jenkins, GitHub Actions, Terraform, and different clouds for that matter. So I would love that all of you can connect with me so that we can create a network out of it. So coming to the agenda for today's basically dev workshop, or you can say a webinar, as Anna mentioned, that we will be covering what is DevOps. There is quite a myth around DevOps that how can we basically implement DevOps, what are DevOps, how can we move towards the DevOps career path. So I will try to cover all of these questions in today's webinar. Also, we will be covering why should you move to DevOps. If I am saying that I'm a DevOps engineer for more than 5 years and I am teaching you DevOps, so why should you as a participant move to DevOps field? Is there any benefit for you or not? Other than that, we will check the DevOps trends, the best practices, and what is CICD. You might have heard about it, continuous integration, continuous delivery or deployment. We will be looking into that. Also, why DevOps is one of the hardest jobs to fill. So we will be looking into the tools that are required if you want to move to DevOps field. Also, in the end, we have a demo of a sample Go language application with GitHub Actions on Kubernetes, where we will be covering the CI/CD part. Okay, so what is DevOps? When everyone says that we want to implement DevOps in our company or we want to move towards a DevOps-based culture, so what does that actually mean? So what happened was that in 2010, or basically 10 years ago, I would say 10 years ago, there was a huge demand of software engineers because every company wanted to have some software for their company, for their applications, or basically they wanted a website, they wanted a mobile application, they wanted something out of it. So software engineers demand was quite high at that moment. Everyone wanted a software, so they hired software engineers, and you can see the boom in the software engineering field. But today, as of now, almost I would say 90% companies has software. They just want to maintain it, or they want to basically update it with new features frequently. They don't want to stay behind. They want to update it, and they want it to stay up, or basically maintain the uptime for their application. So for example, in the last 1 year, you can see there was one issue with Google. The Gmail services went down, so even that was for, I think so, 10 to 15 minutes, but that caused a global outage. Everyone started posting about it, so everyone started asking that why did Google went down, or what did happen actually. So Gmail and other services, they actually went down for 10 to 15 minutes. Then there was an issue with a CDN site, fastly.com, even stackoverflow.com went down. So again, these were all global outages. So what the companies now want is, they want lesser and lesser outages, and they want their features to be frequently deployed onto the production server. They don't want delays. If a feature is complete, why should anyone wait for anyone else? Rather, it should get deployed onto the production server as frequent as possible, and then obviously diagnose issues on the servers. If there is any problem in the server or in the production server, there is memory leakage or anything of that sort, so you can easily debug that and basically work on it. Then comes the shifting blames part. So what previously happened was that there were different teams, developers and operations guys. So developers, they just needed basically knew how to code, and the operations guys, they didn't know how to code. They just set up their the infrastructure and set up the servers, physical servers actually. So what happened was the developers wrote the code, they run the code on their local machine, and it worked fine. But when that code was deployed onto a production server or onto a dev server, it did not work because of unknown reasons, and they both shifted blames on each other. The developers blamed the operations that it is your issue. The operations, they blamed the operations basically blamed the developers that it's your issue. So that shifting of blames happened, and in the end, the company suffered, and in the end, basically the application suffered, as they were not able to deploy their application on to production as frequent as they wanted to. So again, delays came when what they were deploying to dev, then waiting for the confirmation for ops. Then the QA guys, they jumped in, they had all the had to do the testing part of it, and then everything was done. Then they had to move to production. So it was quite a headache that they had to just basically add a new feature to their application, and it took a lot of time. Even it took months just to release one feature. I personally have been in companies where this was the case. Basically, we deployed onto the dev server, then basically we had some testing to do for that, then we had to fill a form 10 to 20, 15 basically questions in it that we had to fill, that whether we have used an a dependency or not, or many other things. And then the operations guy, they basically confirmed us that now you can, okay, now you can deploy onto the production server. So that was quite a delay that basically management was quite not happy with. So it can take days to release a new version of the software. And then after it has been released, you ask the customer, you ask the feedback from the customer that, okay, now this is the new feature that you wanted, so how does it look? And then the customer says that I didn't want this. Because customer as a whole, if you have been working in the software industry, you would know that customer does not even know that what he wants. Even he would be saying one thing, that I want this feature, this feature, this feature, but once you deploy that, the customer will back out. The customer will say, I did not want this, I wanted XYZ. So that is quite a headache. Then now after all of these days and all of these waiting, the feature has been released, but now the customer says that I don't want this sort of a feature, I wanted another feature. So now you have to go back again and basically deliver the complete cycle again. And again, it will take weeks or months to basically deliver that. So why would customer stick to you if you are taking weeks or months to deliver to your customer? So why would a customer stick to you? He would simply shift to any other vendor, and he will try to make his software from there, or basically he will just shift from there. So that's an issue. And again, it was the another issue with the DevOps cycle. The previous DevOps cycle was it worked fine in dev environment, but in ops it did not work fine. So the dev environment is working fine, but the same piece of code when delivered to production, it is not working. So just to pause over here, I will ask from you guys, any one of you, if you can basically think about that, how and why was this the case, that why would this happen, that it was working fine in dev but it's not working in production or any other environment? So how and why can that happen? Any one of you can comment in the chat section or anything, so we will come back to it. You can comment in the chat that whatever you think that it's the reason because of it. Okay, so I will just come back to it in a few moments, so you can guys can type in your answers over there. So the what was the result out of it? The outcome out of it was basically the product delivery cycles, they continue to move slower and slower. The company that you are working in is now taking less ambitious projects, because obviously there are a lot of delays. You cannot take another project because you have not even fulfilled the previous project as of now. So organization is not able to provide stable, reliable service to customers, and that's quite a headache when it comes to the software world, because every day things are changing. So if you believe that Facebook is trying to release a new feature and it takes months to release it, for example, if we say the story feature of Snapchat, that so you can basically post a story out of it and then other people see it. So Snapchat was the first one to release that basically feature, but now Facebook even has it, now WhatsApp even has it, now every other software that Facebook has the story feature. So if Snapchat had basically gotten through over a delay, so they would have lost a lot of market. Now Snapchat is the biggest market at the moment. So we don't want, the competition is quite high at the moment at this time of basically the software competition is quite high. So you really want to be on top of your game, and you really want to deliver the software at a high quality pace, and even at a high pace and even at a high quality. You want both of those things. So now coming to the answers, yeah, uh, different OS, yeah, different environments, incompatibilities, poor planning, OS configuration, prod environment issues, inappropriate resource allocation. All of these answers are correct. All of you, basically, whoever posted the answers, all of these are almost correct. So what happened was that in the dev environment, I was using Ubuntu. For example, I am the developer. I would be using Ubuntu on my local machine, and I would be developing for that. And now the production servers, they are mostly, basically, they are of RHEL, the Red Hat Enterprise Linux, or any other, let's say, flavor of the Linux operating system. So both of them will have different package managers as well. For example, Ubuntu has apt get, and RHEL has yum, or let's say APK, for example. So the package managers would be different. For example, I am deploying Java 8, and on the production server it's Java 11. So obviously that will cause an issue over there. Secondly, what happens is that I am running my local application locally on my local machine. So I don't have any other application running. So for example, my application is running on port 8080. So when the ops guy tries to deploy the same application on the production server, there is already another application running over there, which is also running on port 8080, or there is any other service that's running over there on port 8080. So port conflicts will also occur, because locally I don't have that software. I am running it, it's running fine, it's port 8080, and it's deploying quite well. But when it goes to the production server, there also another application is running on the port 8080, and it will have port conflicts over there. So that is one reason. The dependency versioning is one reason. The other reason would be that the ops guy, they don't know how the software works, and they can't even understand the code part of it. So they cannot read that and understand that what's happening in the code. So these are all some basically answers for that. Now coming to how it evolved from the initial to now, all of you would have listened about the waterfall software delivery lifecycle, that how, or software development lifecycle, that how waterfall worked. So what happened was that, for example, you have 4 months to complete a project. So what everyone did was they took 3 weeks or 1 month to design it. For example, there was a SRE document, software requirements document. You had to go and fill in the software requirements, that what the client wants, and other, and all of those things. Then you took 2 months to code that part. So 3 weeks or 1 month to design it, 2 months or 3 months to code it, then 1 month for testing, and then you deploy it, and it goes to the customer. Now the customer says that I don't want this sort of software, I didn't ask for this feature. That's quite common. That's quite common. If you think that this does not happen, if anyone over here has an experience in the actual software industry, he would know that this is quite common. The client will always back out that I did not want this sort of feature. So now again, you have to change all of this. Then came the agile methodology. In agile methodology, what we used to do was we broke the complete basically cycle into different iterations. So we basically created different iterations out of the whole time that we had. For example, we have 4 months, so we created different iterations, different sprints of 3 weeks, let's say. So of 3 weeks, we will have almost 5 to 6 sprints that we will work on it. So what happened was, we will design it. For example, first sprint would only be for the designing and planning part of it. Then the next sprint, we will code just one feature, not the complete application, just one feature of that application, and then test it. And then another sprint will come, we will code it, test it, code test, and then at the end we will sort of deploy it. And after the sprint ends, basically we deploy the code, and then we can take feedback from the client. So what happened was that it was an improvement from waterfall, because in waterfall we were taking feedback after 3 to 4 months. Now we are taking feedback after every sprint, that okay, this sprint has been completed, it was a 3-week sprint, now we deployed it onto the production server, tell us what do you think of it. And now the client can also basically give periodic feedback. The client can say, okay, basically it's different client can basically say that or he can also give periodic feedback. So he can give on feature 1 that okay, I did not want this, I wanted this. So now the change is quite small, you just have to change feature 1 out of it. So all of these are sort of different methods. Then comes the DevOps part. In DevOps, the basic purpose is that if the code is correct, you deploy it as soon as you have the confirmation that it's correct. Basically, you code design it, you code, test, and deploy. Code, test, and deploy. If one feature is complete, deploy it. You should not wait for any other features. For example, in Agile, we were waiting for a sprint to end and then basically have a sprint retrospective and sprint planning and for the other parts. But in DevOps, what it means is that you will have continuous deployment in DevOps. Whenever the feature is completed, you can deploy it onto the production server. But when I say that the software or the feature is completed, that is the main thing, that I am saying the feature is complete, but how can you get to know that the feature is complete or not? So that is the job responsibility of a DevOps engineer, that how will he be able to manage all of this? How will he be checking that if the software is correct or not? And how will he be checking that, and how can he deploy the software to the production environment in the quickest manner possible? So there is a question, that is DevOps a project management technique or practice, since it is being compared with Agile and Waterfall? Okay, so basically, yeah, DevOps is sort of a culture or a philosophy in the software development lifecycle. DevOps is a culture that you have to basically shift in your organization. It cannot happen that the managers, they are using the previous methodologies and you just hire a DevOps engineer and that will solve all your problems. That will not. We will come at the end of it. At the end, we will discuss as well that uh, DevOps engineer role is separate, and the DevOps philosophy, the DevOps culture, that needs to be embedded inside the organization. That's not a job of a DevOps engineer. He cannot change the culture of the organization at once. So what he can do is he can tell the benefits of DevOps methodologies to the management, but obviously at the end the decision needs to be taken by the management, and you have to basically adapt to that culture and adapt to that philosophies of DevOps. But even some people argue that there should not be a DevOps engineer position. The developers and those guys, they should be able to do the DevOps part. So again, my point being, again, even if that is the case, you don't want to hire a DevOps engineer, you want your developers to manage that part. So again, you would be needing to learn or basically learn different technologies which are required for DevOps, which we will be looking further on. So is a lot of tools and technologies required to implement all of this, because you need to automate it. This cannot be manual, because if this is manual, there is a high chance that there can be an mistake by a person, and the basically default or faulty code goes to the production server. So we don't want that. We always want to only the right code, the correct code goes to the production. So we need to automate this part. So that's the job of a DevOps engineer, to complete all of these things. Okay, so again, coming to Agile versus DevOps, this was a sprint part. We planned, designed, developed, test, deploy, review, and then we sort of launched it. In DevOps, whenever you search for a DevOps architecture or DevOps, you will always see this sort of a diagram. So again, this is the dev part, the planning, coding, building, testing, releasing, and these are the operations part. So a DevOps engineer would be responsible for all of these things, all of the automation that is required to deploy the software and to maintain the uptime of the software. So you cannot, the DevOps part is not only just the development thing, he will also be responsible for the operations and the maintenance part of the application and the monitoring part of the application, that whether it's correct or not, or whether my application is working fine or not. So what is DevOps, and some basically the cultures that I mentioned or the philosophies that I mentioned for DevOps. So some of them is continuous feedback. You take continuous feedback from the stakeholder. If the code is correct, that which I meant basically the code is, the feature is completed, the feature is correct, it is not basically making an error in your application, or basically your application is not getting down, so you release it to the production and take the feedback from stakeholder as soon as possible. But if there is an error, you fail fast, you basically find that error and you give feedback to the developer. So if the code is correct, you take feedback from the stakeholder, which can be your customer, which can be your project manager, which can be your product manager, who needs to see it and take decisions out of it. And if it's the error is, there is an error in your code, then you take feedback from your developer as soon as possible. So what DevOps is: continuous feedback and quick release or fail process. So if it's correct, release it. If it's not, fail it and tell the developer as soon as possible. Previously, what happened, even I have experienced it personally as well, that there were nightly builds. So in the day, the developers wrote some piece of software or the code, and in the night the pipeline will run and it will check whether the code is correct or not. So what happened was, in the night when the pipeline ran and it found that there are issues in the software, so the whole day development that the developer did is now gone to waste. Because obviously tomorrow when he will come again, he will check that the pipeline has failed, he will again fix those things. So and even if his features are completed, he will have to wait for the pipeline to end, so he will continue his work by tomorrow. So again, that's a wastage of time for the developer, and we don't want that in our company. So DevOps means that take quick feedback rather than waiting for nightly builds. You run the pipeline at once and check whether it's fine or not. So what is DevOps? Again, this diagram, as I mentioned, that you will always see whenever you type DevOps, you will see this sort of an application, the sort of an architecture or an image on basically Google or anywhere where you look for. These are some definitions of DevOps from Wikipedia, AWS, and other. So these are some formal definitions. I will not be going into much details for it because obviously these are formal definitions. Just we will go through it. DevOps is a combination of software development and operations. DevOps is a set of software development practices that aim to shorten the system's development lifecycle while delivering features, fixes, and updates frequently in close alignment with business objectives. So again, as I mentioned, that we want a quick release or fail procedure. So we just want to shorten the development life cycle and basically fasten the delivery life cycle. Okay, DevOps is a way to deliver software with shared pain and responsibility. DevOps ultimately means building digital pipelines that take code from a developer's laptop all the way to revenue generating products. So again, if you ask me a layman terms definition of DevOps, that what is DevOps, a layman term definition, if none of you is a software engineer, but you want to know what DevOps is, so I would say that DevOps is a way by taking software from a developer's machine to the production, and all the steps in between are the job responsibilities of a DevOps engineer. He has to build pipelines, he has to build anything, he has to automate anything, all of this, that is his part. So and obviously we want, the company wants to generate revenue, so that is the main purpose of the basically company. So we want to fail fast or release fast, whatever is the way. Okay, so now coming to why should you move to DevOps? We have learned what DevOps is, basically the fundamentals or the principles of what DevOps is. But why should you move to DevOps? Is there an attraction over there, or is there basically a need for DevOps as well, or not? Or is there no need and we are just announcing it? So let's see what why should you or anyone move to the DevOps field. So these are some Google trends that has for the DevOps part, and it has been increasing exponentially, sort of. And now coming to the salary part, obviously we all want a better salary for ourselves, and that's the major reason. And we want some basically established life, and for that. So these are some average salaries in the Europe region for 2018. So you can see these are different. Now coming to, okay, so these are some trends that are from the Stack Overflow blog. Stack Overflow is the website that every developer would have heard of, even if he's in university, he's in college. If a person has developed software, he would have heard of Stack Overflow. So these are the different trends from Stack Overflow's surveys that they conduct every year from their salary calculator. So these are different trends that I will be sharing from 2018 till 2021 till now. So we can see DevOps is the highest paid job. DevOps engineer in Germany, in India, data scientist even Even they are at below DevOps specialist, full stack developers, back-end developers. So we can all see this. Similarly, in United Kingdom and United States, for 2018, again, DevOps specialists is the highest paid job. We all of us would have heard of data science, or all of us would have heard of full stack engineers, but some of us might not have heard of DevOps. But as you can see from here, that DevOps is the highest paid job in the global world. Similarly, these are the stats for 2019, same Stack Overflow blog for 2019. Again, DevOps is the highest paid. Data engineer, data scientist, backend, they are all below DevOps in United States, United Kingdom, India, Germany. DevOps is the highest paid job in 2019 as well, based on the survey of Stack Overflow. In 2020, again, engineering manager is the highest paid job, but obviously that is a management job. So after that, again, site reliability and DevOps. So site reliability engineer and the DevOps engineer are sort of the same role, but there is a minor difference in them. But sort of, you can say that major parts, or almost 60 to 70% work would be same for an SRE engineer or a DevOps engineer. So again, they are at the top. Data engineer, data scientist, they are below those things. And this is for 2021. I missed to change this. So again, this is from 2021, not 2020. Again, engineering manager top, senior executive, VP above it, and then site reliability and DevOps specialist comes at the second position. So basically, again, DevOps is one of the highest paid and the most sought out jobs in the whole world. Why it is, that I will tell you later on, because there are a lot of technologies, a lot of tools and technologies required to learn for a DevOps engineer. So DevOps engineer, even though the salaries are high, but that's not an easy job. That's a quite difficult job. As I mentioned, that in the last year, you all know that Google went down, the gmail.com and different services of Google, they went down. Similarly, fastly.com, a CDN site, that went down. So no one ever praised the Google engineers that their services have been up for so many time. For I don't think so. I have never heard of a downtime in Google until this one. No one praised them. But as soon as google.com or the Gmail services went down, everyone started blaming the DevOps engineers, or basically the Google employees, that how they went down. And obviously the Google management would have asked from the DevOps engineer why this happened and all of those things. So again, DevOps is a thankless job, because the application is up, no one will praise you, or no one will basically buck up you. But as soon as it goes down, everyone will you will start receiving a lot of emails, a lot of Slack messages that your application is down, what happened, what did you change, or what happened. So again, as I mentioned, that DevOps is a difficult job, but that's why the companies are willing to pay a higher salary than other jobs as well. So there is a pro and con in both of these. But obviously, what I prefer, it all depends on one's preference as well. My preference is this sort of a job where you have the ownership, where you have the responsibility to manage the production servers. Obviously, I am the one who is managing the production things. For me, that ownership is one thing. So DevOps engineers ownership is also another trait that you need to have. This is a Glassdoor survey. This is in 2019. The average salary was $115,000 in US for a DevOps engineer. Again, DevOps engineer is the hardest job to fill. These are different articles claiming this. I am not claiming this. These are different articles. These are HR professional claiming this shortage. This is again hardest job to fill. This was in 2016. These both are in 2021. And especially after COVID, when things have went either remote or hybrid, that you need to work online, or you can work from home, or from office as well, the hybrid work, the software dependencies have increased now. So all of these things now, DevOps demand is even higher than ever. The recent acquisitions that have happened, Microsoft acquired GitHub. GitHub is again a major part of the DevOps cycles. The CICD, GitHub provides GitHub Actions. IBM acquired Red Hat. Red Hat, if you most of you don't know, Red Hat is one of the major players in DevOps field. It is one of the major players. It has OpenShift platform. It has a lot of other things that it provides, and most of it is open source. But they basically handle the support part, and basically they take money or they make the money out of that support part. Red Hat is one of the major players in basically DevOps. Mirantis acquired Docker. Again, Docker, if you most of you don't know, Docker is a company that enabled to ship images and ship Docker images so that most of the developers can easily share the images. Okay, so how to become a DevOps hacker, man? How can you basically shift to a DevOps field if you want to, and how can one learn basically the pathway to move to a DevOps field? What can that be? So there are different sort of basically DevOps best practices which you can follow, and there are different tools for each of the practice that you can learn to if you want to move to this field. The first practice and the first thing would be continuous integration. What continuous integration means is that what basically you merge the code changes from different developers into a central repository. So again, for DevOps, you always need a version control system. It can be Git, it can be TFS, it can be any other. But Git is the most popular one, the most popular continuous integration or basically the version control system tool. Git is the most popular one. GitHub is a provider of basically Git. GitLab is again Bitbucket. These are all different providers where you can use Git as a version control system and handle your code and handle basically merge different changes from different developers. Okay, so continuous integration means that you merge the code changes into a central repository as soon as possible. So I, as a developer, push some changes or I push the changes for a feature. So automated builds are run, automated tests are run, unit tests are run to check whether my software is correct or not. Unit tests run and they basically give me the whole feedback that if the software or if the code is correct or not. If it's correct, you integrate it into the main branch. So there are different branching strategies that are implemented to solve this or basically to enable continuous integration. So a developer would come, he will create his own branch, he will make the changes, he will push the changes, pipeline will run, you will create a PR. Again, we will see this as a demo as well later on. But you will create a PR, and in that PR, automated tests can run, automated things can run, and then you will basically merge that onto the main branch, and then obviously the production or any other environment you have, for example, dev, QA, prods, any other environments deployment will start. So the key goal is to fail fast. If the code is not correct, obviously the unit tests will fail, and the developer will get to know that okay, my code is not correct, I should fix it. So the key goal is to fail fast and find and address bugs quicker. So again, what DevOps means is it is already validating all the principles of software engineering as well. You need to write unit tests, you need to write some way of code static analysis, basically static code analysis. You should analyze your code, whether my code is syntactically correct or not, or my code is conceptually correct or not. For example, I have used a variable that is not being used in all of the basically code. So you can use different tools for it. SonarQube is one of those tools through which basically we can analyze the code, whether my code is correct or not, or it has some issues or not. So it benefits the developers most. Obviously, you are pushing your changes continuously, and then you can see you can merge those changes. So again, less merge conflicts. Also, obviously, you are merging quite frequently, so there will be less merge conflicts. So this is sort of how continuous integration works at Silver Stripe. It's a company, again, how they basically use continuous integration. So from Git, it goes to GitHub. The developer basically pushes his changes onto a feature branch. Unit tests are run, code analysis is done. Again, this is SonarQube. You can use any tool for that. The code analysis is done. It analyzes your code, whether there is an issue or not in it. Then you get the test coverage and all of that. And then if all of it's correct, you release it. Basically, by releasing, what it means to merge that branch onto the develop branch or onto the main branch, whatever branching strategy you are following in your company. So that is when. Now comes the CD part. CI was the continuous integration, now CD. So for CD, there are two things: continuous delivery and continuous deployment. So over here, this diagram explains it better. So this diagram is from Edureka, again, giving references to there. So continuous integration is done, automated test is done. Now you deploy it onto a test environment or a staging environment, whatever name you can give it. You can sandbox, test, staging, QA, pre-prod. All of these environments can be included in the continuous delivery method. So you deploy there again, the integration tests. Previously in continuous integration, we looked at unit tests. Now we are looking at integration or end-to-end tests that are automated, that are run basically on the UI, or there is a manual tester. If you have not implemented automated testing, then there can be a manual tester, basically, which will be testing the changes on the staging environment. And once that is done, if you deploy manually to prod, that's continuous delivery. But if you deploy automated in an automated way to production, that's called continuous deployment. So what can happen over here is that you created a deployment, it went into the test environment, it went into staging environment. You had automated tests that run on that staging environment. The tests pass, and now you can deploy it onto the production in an automated way. So if it's automated, it's continuous deployment, as the word suggests, deployment, that we are deploying it onto the production environment in an automated way. But if there is a manual step involved in between, that's known as continuous delivery. Again, the word as it suggests, that we are delivering the software till the final part, but we are not deploying it. We are delivering it till the final part, but the last part would be manual. The production part would be manual. So that's a major difference between continuous delivery and continuous deployment. So now basically these are two major principles. Whenever you will hear of DevOps, you will always basically read CICD. CICD is a major part of DevOps. You will be the job of a DevOps engineer would be to write pipelines which do all of this part. All of this part, that deploying it on a test environment, running automated tests, deploying it over here, running unit tests over here. So these all parts are to be written by a DevOps engineer. He would be writing the pipeline to run these unit tests, to run these code analysis, to show the test coverage and all of this. This is the job of a DevOps engineer. So now coming to the tools related to CI/CD. Again, DevOps is a field where there are a lot of tools for each and every thing or each and every technology. So for CI/CD only, there is Git, SVN, TFS. Okay, if you use Git, then there is GitHub, GitLab, Bitbucket. For CI/CD, there is Jenkins, GitHub Actions, GitLab CI, Tecton CI, Circle CI. Some company would be using GitHub Actions, others would be using GitLab CI, some would be using Jenkins. So as a DevOps engineer, you must be familiar with these. Even if not, you have expertise in all of these, but you should have familiarity with all of these tools, or even just know the basics or have expertise in one of them. For example, one can have expertise in Jenkins, but just know the basics of this. So that also matters. Or even if you go to the cloud, so each cloud provides its own CI/CD tools. For example, AWS Code Pipeline, Code Build, Azure DevOps, IBM DevOps, Flux, Argo CD. These are some GitOps tool that are for Kubernetes. So the amount of tools just for CI/CD are quite much. And if you see job descriptions, you will always see Jenkins or GitHub Actions or Circle CI. So you might have experience in one of these, but not so expertise in one of these, but not in all of these tools. So The next principle is microservices. So what are microservices and what does they mean? So basically, when we started writing software, when the software basically was booming, there was how we wrote software, that we wrote all the code in just one file. Then came the OOP concept, the object oriented programming, where we used functions, where we used classes, where we basically broke the single piece of code into different functions, into different classes, and basically made it an object oriented sort of. So the microservices also work on the same principle. Rather than having this single monolithic service, the opposite of microservices, monolithic service. So for example, I have an e-commerce website. This is a shopping website. I have different basically business units inside it: accounts, orders, promotions, inventory, products. Then we have a data layer which will be accessing the database of it, and this is the UI part where the customer will come and basically check it. So this is a monolithic service. So rather than handling all of this, for example, on a Black Friday sale on Amazon.com, for example, on a Black Friday sale, the most of the users would be there just doing window shopping. They will not even log in to your website. They will be basically doing window shopping for you on your website. So the major load would be on the inventory or on the products, because everyone is looking at your products. The orders business unit is not even being used at the moment, but the major load is on products, because everyone is visiting your website and the load is being called onto the product site. But now you have to scale it up. How can you scale only the products part? You have to scale the whole application. And if, for example, there is an error in the products part, all of the application goes down. So that's the issues of monolithic service. So now what we do is, there is this architecture, microservice based architecture, which recommends us to break the monolithic service into a microservice based architecture. So over here, what we will do is, these were all the business units, and this was one application. Now we broke it into multiple applications, and each of them will be calling them through their API. Basically, accounts will be calling the order service, orders will be calling the product service. So this is how an API sort of workflow will work. And this is the front end, which will be calling the backends for the data, and front end will then be displaying that data over here. And each microservice will have its own database. Okay, one other question I have for you. What is the use of having multiple databases? Why can't we have a single database like we had over here? Can we have a single database and have just separate microservices? Would that be better, or having separate database per microservice is better? And why is that so? What do you guys think? You can write again in the chat what you think about it. That should we have separate databases for each microservice, or a single database, and why do you support that part? So I will come to it in a moment. You can, all guys can basically answer in your question, answer in the question in the chat. So these are different microservices based architectures, and these are some major players which have adopted microservices based architecture. There is a Hail, Netflix, Twitter. They have 500 plus microservices. So now coming back to this, the description of microservices. So what you will do is, you will build a single application as a set of small services. So rather than having one service, we will be having smaller microservices. Each service runs in its own process and communicates with other service through a well-defined interface, the API calls that I mentioned. Each service can be updated and deployed independently. So again, if there is a change in the promotion service, for example, we have changed the promotion service. In monolithic service, you had to wait for all of the code to be correct. My promotions, I am responsible for the promotions part of the business unit. My code is completed, but I still have to wait for all the other codes to be completed, and then my application can be built. But in a monolithic based architecture, if the promotion service is correct, I have completed my feature, I can release it as soon as possible. I don't need to wait for these other services. Similarly, what we can have independent CI/CD pipelines for all of them. We can have independent ownership. We can have independent responsibility for each of the microservices. So what will happen is that I, as an owner of promotions team, I can deploy my application whenever I want, because as soon as the feature is completed, I will release that. So these are benefits of a microservices based architecture. And the tools, okay, now coming to the answer. Separation of concerns, separate, avoid single point of failure. If we have 1 DB, then the dependency will be there. Bottleneck, single point, separate. Yeah. So all of, again, most of you have answered correctly that, okay, one has not, one participant has not. Basically what, if we have a single database, the issue with that would be that if the database goes down, for example, over here, if the database goes down, even if I have a microservice based architecture, that will not help me because the database is down, all the microservices will be down. But over here, if the promotion service database is down, will it affect any other microservice? No. So the major reason is separation of concerns, not having a single point of failure. If single point of failure means that if that single point goes down, all of your application will get suffered, or basically will suffer because of that. So we don't want that as users. Okay, and when we move to a microservice based architecture, there are a lot of related tools that we need. For example, we will be needing API gateways for it, because API gateways will basically route your application to the respective microservice. We will be needing messaging queues. For example, over here, if order service sends a request to product service, but product service is down at that moment. So in a previous architecture, what will happen is that that request will get basically deleted, or basically the product service will not get that request. For example, I placed an order, the call went to order service updated the inventory service. Basically, I have bought a shirt, for example. Now the inventory for the shirt should get decremented, but inventory service was down at that moment. So my request, that request will go basically in a zone. Basically, it will not reach the inventory microservice. So now what will happen is that now your database is not correct, because I have ordered a shirt, but that result, that basically change, is not reflecting in the inventory microservice. So what we will do is we will have a messaging queue. Order service will put that request in the messaging queue, and inventory will read from there. So now that's a need we want to have in our architecture, a messaging queue. So even if my inventory service is down, that request will remain in the messaging queue. And as soon as the inventory service comes back up, it will read from the messaging queue and update its database. So now we need a messaging queue as well. So these are sort of, and then obviously containers, Kubernetes, serverless, service mesh. These are different tools that are sort of necessary if you are moving to a microservice based architecture. So yeah, microservice helps as well, but these are some sort of different tools and technologies that you need to learn when you are moving to a microservice based architecture. So okay, yeah, when your boss tells you we are converting to microservices, so obviously containers are necessary. You can equate containers are the most necessary part when a company wants to shift to microservices, because obviously they are the way to run containers. You cannot create VMs for it. I will not be covering containers versus VM in this class, but obviously if you enroll for the class, we cover each and every part of containers, Kubernetes, Git, GitHub, and those things. And then obviously we need Kubernetes. These are the transitions. Basically, if you have the monolithic service, you move to microservices, you deploy that to Docker. Now you need to deploy your containers onto Kubernetes, because again, containers cannot be run in a well way without Kubernetes or without an orchestration tool. So these are required tools, and Kubernetes is the most popular tool for orchestrating containers. These are some of the popularities of containers. So Kubernetes manages containers at 69% of organizations. So Kubernetes is the default container orchestration tool being used mostly. Amazon ECS, AWS ECS is one of them. Docker Swarm is there. Google Container Engine. But again, these are some quite small numbers. Kubernetes is the largest number that is being used in the industry for basically managing containers. Again, Kubernetes adoption in 2020, 92% of organizations use containers, and 83% of them were using Kubernetes for containers orchestration. So we cover Kubernetes and containers quite in detail in the class. And again, these are different offerings that different clouds give us for Kubernetes. So again, the adoption has increased. In 2020 it was 47, now 54. So people are shifting to cloud managed Kubernetes offerings. Please explain working of Kubernetes briefly. That would not be possible. I'm sorry for that. Kubernetes cannot be explained in a 2-hour session. For that, we need a lot of time, and that because obviously Kubernetes is one of the major tools, and it needs time, a lot of time for it. So coming to cloud computing, again, that's another principle for DevOps. Cloud computing is a part of DevOps complete cycle. So most of you would know how important it is cloud computing and how cloud computing is gaining popularity in the world. So the benefits of cloud computing is on demand computing resources. You don't have to buy resources. For example, I have an application. Should I be buying a server for it, or should I use cloud's resources so that I pay whenever I use it? For example, for this demo, for the demo that I have after this basically webinar, I spinned up a Kubernetes cluster. So if and after this webinar, I will delete that cluster. So again, I will just be paying for the time that I used the cloud's resources, not all of the time. If I buy a server, I will basically pay a one-time amount, and then I will have to manage it always. So that's a drawback of managing the servers yourself. If you have a cloud-based computing basically service, you don't have to manage the resources. The cloud will provide you the SLA for it. That cloud will basically bring your services up or keep your services up based on the SLA that they provide. Again, these are elastic resources. So for example, as I mentioned previously, I for Amazon.com, for example, on a Black Friday sale, what happens is that there is a lot of load on my servers. If I have servers with me physically, I would have to buy a whole server for it, because obviously load is increasing on my website and I want to maintain that. So I will have to buy a new server. But again, only the load comes on one day where I basically publish a sale. But all the other year, there is no load. My one server is able to handle that. But if there is a sale, I have to basically consume two servers. So if I go to cloud, what can happen is I can easily provision a new server on cloud, and I will just be paying for that day only. So you can easily scale up or scale down to meet the demand whenever there is self-service. You can go, all of the clouds have a console where you can go and provision any service that you want. Please explain future of Kubernetes versus container. So Kubernetes is the future. If you basically search for Kubernetes, Kubernetes is the present as well as it's the future. As I mentioned previously, Kubernetes, the surveys that were basically conducted, so 92% companies were using containers, and 83% of those organizations were using Kubernetes for containers orchestration. So Kubernetes is the future. Is even it's the present. Even major companies have shifted to Kubernetes. You can search the Kubernetes job trends on Indeed.com. If I remember, it was a 177% increase in job search related to Kubernetes. There are different certifications for it. Kubernetes is an open source Kubernetes container orchestrator. The major benefit of Kubernetes is it's open source. So if I face an issue on Kubernetes, I can go and make a PR or basically contribute back and fix that issue. And that is what happened. The developers, the community members, what they did was whenever they faced an issue, they solved that issue on Kubernetes. And now Kubernetes is the default way of deploying containers. If you search a bit on it, so Kubernetes is the default way of deploying containers at the moment. Okay, so there are different clouds, all the major providers. AWS is from Amazon, Azure is from Microsoft, Google Cloud, Oracle Cloud, IBM Cloud, DigitalOcean, and then there are different providers that are using OpenStack for cloud provisioning and those things. So again, cloud computing is one of the other fields that is quite booming, but a DevOps engineer should be aware of cloud computing and its technologies. The next thing comes is infrastructure as code. So as I mentioned that you need to provision infrastructure, you need to create servers, you need to create provision basically servers on the cloud. So rather than doing that manually, if any one of you have ever provisioned a server on AWS, it asks you around 15 to 20 questions related to it. You have to fulfill basically all of those things. So what you can do is, for example, I have a Java application and I have different servers and I have different environments. What I can do is I can install Git on it, install Jenkins on it, install Tomcat, install database, and install Nagios for the monitoring. And then I will also need to configure the users for each VM or each server. But what if you need to do the same thing on hundreds of servers? You have to basically do the same thing on hundreds of servers. Would you be provisioning hundreds of servers manually? As I already mentioned that if you have to provision an EC2 instance on AWS, you have to fulfill basically 10 to 15 questions on AWS console. So if you have to provision hundreds of servers on dev environment and then install Git, Jenkins, Tomcat, database on all of them, and then for the QA environment, then for pre-prod, then staging, then production. So that's a lot of tasks to do. So rather than provisioning manually, we provision through code so that whenever that code is run, it will provide or basically it will provide the same results. We can run that on one server or we can run that on hundreds of servers. So that's not an issue. We can always basically provision the infrastructure through code and it will never ever change the results. For example, even if manually there is a chance of error, for example, I have to provision 10 servers and in 8th server that I was provisioning, I got a bit lazy and I misspelled one step or basically misspelled a thing. Again, that's an issue. A chance of error can occur in when you are doing things manually. But if it's through code, you can easily see easily there is no chance of error as well. And also there is in manual cases there is a chance that I changed one thing manually but now I don't remember it. So for example, on 1 year ago I changed the configuration of my server, but now I don't remember that what did I change because that was a manual step. But if you are handling the infrastructure through code, you can easily go to the basically the version control system that you are using and easily see that what was changed in the code or what was changed on the server. So again, infrastructure as code is another major best practice for a DevOps engineer to learn and implement in the company. Benefits are recreation of environment. If you want to recreate an environment, So again, provisioning hundreds of servers, again, that will be an issue. But if you have code, you can easily provision all of those. Deploy everything in an automated way or through scripts. Main purpose is to have state and deployment manifests in any central place. So again, all of the code will be at a central place, at a version control system on GitHub, for example. So you can easily see what changed in my servers. There are different tools for it: Terraform, Ansible, Puppet, Chef. In the course, we cover Ansible, and we also cover a basic part of Terraform, but we cover Ansible as a whole. Again, this infrastructure as code, this can also lead to GitOps. That is another major concept that is gaining popularity in the world of Kubernetes. So infrastructure as code can lead to GitOps when you are provisioning Kubernetes manifests. Okay, let me see. Can we use multiple languages in microservices architecture? Yeah, again, one other benefit of microservice-based architecture is we can have multiple languages. My inventory microservice can be in Python. My orders microservice can be in Java. Again, there is an issue. For example, there are some companies that have legacy software that is in Visual Basic, and they cannot update it now. They can never ever basically update it, because all of the software that's a legacy software written in Visual Basic, you cannot update it. And the major challenges that such companies face is of hiring. You cannot hire resources because the new resources, they want to work on newer technologies, they want to work on Python, they want to work on Java, on newer technologies rather than working on Visual Basic. So if you have a microservice based architecture, you can hire resources. If one wants to work on Python, you can shift him to the Python based microservices team. Or if there is one that wants to work on Java, you can easily shift him to the Java team. So that is again a benefit of microservice architecture. Based on your experience with public clouds, AWS, which one do you feel provide the best overall DevOps engineering to AWS? Personally, I would say AWS, yeah, because AWS is the most used, is the most simplest, and I would say personally, that's my personal opinion. Again, people can differ from that. That's my personal opinion, that for me, AWS is the most complete sort of cloud at the moment. Okay, the next part is monitoring, logging, tracing, and alerting. So these are some of the major players again in a DevOps based environment. You need to monitor your infrastructure. You will not be looking at the dashboards or the CPU usage, the memory usage always. You need to monitor your applications, monitor your infrastructure as well as applications. You want to have monitoring for all of these things. For example, if there is a CPU usage more than 80% of my server, I want to be alerted of that. If my application is using 70% of the memory resources, I should be alerted of that so that I can upscale my application. I can create a new replica of it. So deploying the infrastructure is not an issue. Maintaining it is. Again, that's a major thing, that you need to maintain your infrastructure. You will be responsible, a DevOps engineer again will be responsible when the infrastructure is throttled, network went down, machines are not working, application is not working. So you will be asked why it happened. So if you have a concrete monitoring infrastructure or monitoring setup, you can easily tell that why it happened and you can easily fix that issue. But if you don't have a monitoring setup, you will just be throwing arrows in the bushes, that what happened, it might have happened, this might have happened, but you would not know the actual cause of why all of these things happened the way it was. So you need to have a concrete monitoring setup to manage all of this. Deploy tools to monitor and see the logs sent by application, shed insights into the root causes of problems or unexpected changes. Again, active monitoring, alerts. So again, you will not be looking at the monitoring dashboards 24 hours. That's not humanly possible. You would have to configure alerts for it. That, for example, whenever my application goes down, I should be alerted. A Slack message should come, email should come. So all of those things, you need to set up alerts based on those. A memory is using, server is using 70% of the memory. So I should be alerted of that this server is using 80% of the memory. So I need to upscale my infrastructure. So that is another thing, monitoring and alerting, that you should set up. And again, this is the centralized monitoring and logging for a microservices based architecture. So these are all the microservices, and there is a one tool for central monitoring which will be monitoring all of these microservices as well as the infrastructure, the physical servers of my basically cluster. And this is the central logging. It will be collecting the logs of all the applications and storing it so that I can basically query them in the future. So again, this is one of the most I would say important thing to have in your infrastructure, because what happens is that if the application goes down, uh, there will be again shifting. You will be shifting blames to the developers. Developers would be shifting blames to you. So developer will at once say that it's not my issue. It's the issue of the physical server. My application is totally correct. So if you have a logging setup, you can easily locate what happened wrong. Was the issue due to application? Because obviously application would be logging it. If you have a concrete logging setup, so you can easily trace that what was the issue, what application logged at that time, and you can easily point it out. So again, rather than shifting blames to each other, we can come to the root cause easily, that what was the actual root cause, whether it was the issue of a developer or the basically source code, or it was the developer on the infrastructure part. So we can easily trace that using a concrete logging and monitoring setup. And tracing, what does tracing mean is basically I have a API call, for example, /dispatch, and when I run this call, it takes around 1.5 seconds or 5 seconds, for example. Now I want to know that how this 5 seconds are being distributed. The 5 seconds call, it's quite a much. Basically, my one API call is taking 5 seconds. Now I want to see that where it is distributed. So that's a concrete graph that tracing tools give you. For example, 1 millisecond it took over here, 500 millisecond it took over here, 1 second it took over here, and then it gives you a complete graph that where that time is distributed. The total call took 5 seconds. That 5 seconds is distributed. For example, over here it took 1 second for this microservice, because now again the call have become distributed. 1 second it took over here, 300 millisecond it took over here. So you can get a complete picture of it. Again, the tools for all of these are Prometheus, Grafana, Nagios, Datadog, Jaeger, Zipkin, ELK, EFK, Alert Manager, Splunk, PagerDuty, and all of these tools are being used in the companies. There is no preference of it. Many companies are using Splunk, many are using Grafana Prometheus, many are using Nagios, Datadog. So as a DevOps engineer, the thing I said, that the job of a DevOps engineer is not that easy. And the reason that it is a highly paid job, because you have to have experience with at least one or two of these tools. So that's quite an issue. These are for the monitoring and logging. Previously, we checked the tools for CICD. Then we checked the tools for microservices-based architectures, containers, Kubernetes, messaging queues, Kafka, Zookeeper, all of those. And now over here, again, for monitoring, there are a lot of tools. So the tool set for a DevOps engineer is quite high. You have to be familiar with a lot of tools, and you cannot back away from basically learning new tools. So that's again the reason that why DevOps is one of the highest paid jobs, because you have to learn these tools. Communication and feedback, again, that's the most important part of DevOps. That's the main reason that why Dev and Ops teams were basically they had issues in between them, because obviously their communication was lacking, their feedback was lacking, the actual investigation of what the issue is and how the issue needs to be resolved, that communication was lacking. There was a different basically responsibilities at that time. So now once you have automated all of this, you should also have a communication way that if the pipeline does not pass, pipeline fails, you communicate it to the developer. If the infrastructure is down, you communicate it to the team that infrastructure is down, I am looking into it. So DevOps was introduced to due to conflicts between developers and operations teams blaming each other. So now you have to fix those issues. You have to bring those teams along. You have to maintain the visibility. Again, if it's a manual thing, it will fail. Not today, but tomorrow, definitely it fail if it's a manual thing. So as a DevOps engineer, you need to automate all of these things so that your manual interference is the least over there. Because what can happen is in the future, the infrastructure goes down because of my fault. What I will do is I will not tell that to the developers, or I will not tell that to the team that it was my fault and that's why the application went down, because obviously my head is at the stake over there. But if it's an automated way, the automation will not care whether it's me or it's anyone else. It will tell me that this application is down, or this error occurred, or this issue occurred. So it will try to basically tell the whole team of that. Again, give continuous feedback to respective stakeholder. If feature is correct and deployed, take feedback from consumer. If issue in code, give feedback to other developers. If issue in infrastructure, communicate to teams as soon as possible. Again, as I said, that the DevOps uh, engineers basically they manage to do these two parts, but somehow they leave this part because this concerns them. So again, for tools for these are Slack, Teams, Jira, Alert Manager for Prometheus, on those things. So now again, DevOps requirements. These were all the tools and technologies that you need. But again, as we mentioned earlier, that DevOps is a philosophy, it's a culture. You cannot implement DevOps without having an agile methodology, without having a stand-ups, without having CI/CD, or static code analysis, or those parts, having pipelines for it. Again, doing manual things is not DevOps. There are many companies, basically they have a DevOps engineer position, but in actual what the guys are doing is they are handling the system analyst part or system administration part. That's not DevOps. By naming a position as DevOps engineer does not mean that you are doing DevOps. You need to implement DevOps in its actual way. You need to adapt to that culture. The major issue comes over there because the people, the management, they do not want to basically shift from their comfort seats or their comfort zones. They do not want to adapt to newer technologies. That's the main issue. So you need to implement or basically adapt to that culture. Again, the summary combination of cultural philosophies, practices, and tools, it increases the organization's ability. Dev and ops teams are no longer siloed. Obviously, the communication will come up, and I, for example, as a DevOps engineer, know how to read the code or read software. So I can also check that what is the issue. Obviously, I might not be able to fix it, but I can also give my point of view in those things if I know the development part. So I, as a DevOps engineer, know the development as well and the operations part of it. So I am a mixture of both of those things. Quality assurance and security teams may also become more tightly integrated. Again, you can have teams divided through the microservices. So for example, you have 5 microservices, you can divide the teams based on those microservices. One team will have ownership of one microservice, and in that team you can add QA and security teams as well. Teams use practice and tools to automate processes. Again, automation is the key over here. Again, the diagram would be the same. Building part, testing, planning first of it, then coding, building, testing, release it, deploy it on production, operate it, and monitor if it goes down or any other issue occurs. And these are some sort of tools that are there are a lot of tools for each part of it, but these are some of the tools that are required. For example, for planning and coding, you need Confluence, Jira, Git. For building, you can use Maven or SBT. For testing, Selenium, JUnit. For releasing the CI part, basically Jenkins, CodeShip. For deploying, Docker, Amazon, TCOS, operating against Chef, Ansible, Kubernetes, and monitoring Nagio, Splunk, Datadog, Prometheus, Grafana. So there are a lot of tools required for a DevOps engineer to learn. If you see an average JD or a job description for a DevOps engineer, so there are a lot of tools mentioned over there. So that's why what DevOps is one of the highest paid jobs worldwide, because you need to have familiarity with most of the tools. And these are just some of the tools mentioned in this diagram. There are some other diagrams that which mention a lot of tools. I thought not to use that because obviously reading all of those tools would be an issue again. So I chose a simpler version of it. But in actual, there are a lot of tools that a DevOps engineer needs to be familiar with. Summary again: CICD release once a week, higher quality of code, microservices. We have covered that these are loosely coupled components deployed in an automated way without waiting on individual components. Responsibility, shared responsibility, common goals, process and culture. Infrastructure again, cloud, containers, Kubernetes, build once, run anywhere. So Kubernetes again and containers, both of them are cloud agnostic sort of. You can build a container that will run anywhere in the same way. The issue that came initially, that it runs on dev and it does not run on the production server, that will not occur if you are using containers. Why is that so? That is the details of containers that cannot be covered in a 2-hour session. Obviously, that's the basically details and ins and outs of containers. So that we cover in the class part. And if you want to become a DevOps engineer, so my suggestions would be, and a summary would be tool independent. So as you saw earlier, that there are quite of tools in each practice or in each field: CI/CD, microservices, containers, Kubernetes, clouds. So there are a lot of tools for that. So be tool independent, gain expertise in one of each tool. So for example, you have expertise in Jenkins for CI/CD, you have expertise in AWS for cloud, but for others you can learn the things. Be tool independent. You learn the basics and you learn and gain expertise in one of them. Be adaptable. Again, being adaptable is one of the most, I would say, primary features for a DevOps engineer. He should adapt to newer technologies. And the same over here, once that I said, that able to learn and unlearn. Basically, what happened was, or basically what happens is that we as humans are not adaptable to change. We don't want change in our lives. So as a manager, if I tell my manager or manager in any company that okay, we have a new tool in the market and that's better than what we are using at the moment, what he will say, or what the typical mindset will say, that we will not update it because we are familiar with this tool. Now we don't want that learning curve on that tool. So that's not how you can basically improve on your infrastructure or improve on your applications, because you should be able to learn new technologies and unlearn the previous technologies that are now totally finished, or basically they are vanished from the recent times. So you should unlearn those. You should be able to accept that yeah, this tool is better, I should learn this rather than sticking with the old tools. And also you should gain some development experience. If you don't know how to write code, I would suggest you to gain some development experience, write learn basically scripts, Python a bit. So those things can help you, so you can even learn basically what is happening in the code. When you are deploying the code, you should be able to learn, or basically able to know that what's happening inside that code as well. So okay, first let me go to the questions. I guess, will we cover any monitoring tools in the course? No, not as such. We will just, I can brief you over it. We will go through the monitoring tool right now as well. But the deployment part of it, we will not be covering that, because obviously, if you can ask any of the alumni of the course, already the course contents are quite high. We have 8 weeks course, and in each week, you are almost learning a new tool. In the first week, it's Git. In the second week, Docker. Docker Compose, Docker Swarm. I think the second, third, fourth weeks goes on Docker. Fifth and sixth, fifth is Jenkins. Sixth, I also cover GitHub Actions, Jenkins and GitHub Actions, a bit of GitHub Actions on that. Kubernetes, sixth and seventh week goes to Kubernetes and Helm, and eighth week is for Ansible. So already you are learning a new tool every week. So that would not be possible to cover in an 8 week course. Typically, it is next to impossible for one drone to be expert in all these. Expert of it almost requires multiple sources to focus and be responsible for specific expert. What is your experience with real life situation? Okay, so basically, what Ali is saying is that how it's impossible for one person to learn all of this. So there should be multiple domains or this. So yeah, there are multiple domains. For example, you would have heard that there is a DevOps engineer position as well as there is a position for a cloud engineer. So now the cloud engineer is responsible for handling the cloud part, the cloud architecture, the cloud things. And DevOps engineer is responsible for the CI/CD part and all those things. And similarly, an SRE, the site reliability engineer, he is responsible for managing the reliability of my infrastructure and maintaining the uptime of my applications and those things. So yeah, there are different domains, but normally what happens is that a DevOps engineer needs to know these tools. Not be an expert in all of this, but yeah, know all of these tools and be able to learn new tools. That's my personal experience. I have been working, and what can I say is that I have worked on all of these tools in all of these domains personally, and I have seen people working on these domains individually. How does working in a regulated environment such as the one in a fintech startup work within effect or change how one employs and implements DevOps? What are the unique challenges one may face in such environment? So yeah, fintech is in a way, basically it's you have to handle the security part, because obviously you are basically managing the financials of it. So the security and those things are quite high, that need to be quite high to basically involve the DevOps inside it. So that is one thing. Other than that, implementing DevOps, again, you need to, the major thing that I believe is having communication within your team. You should communicate with your team that what are you thinking as an architecture of the application, and what they think, and then you can come on a basically combined decision and combined things. So each of these things should be documented first, planned first, and then you implement those things. Would small startups or software based companies be willing to put so much of the resources in DevOps? It is basically some luxury that yes, obviously, you are totally right. That's why I said that some people are of the view that you don't need a DevOps engineer. Your developers should know the DevOps part, but that's not possible, because obviously it's so much of tools and technologies. How can a developer learn these things as well, and as well as implement the code part of it? So that's not possible. That's why the role of DevOps engineers is gaining popularity day by day, because companies want their developers to focus on the coding part and the DevOps engineer to focus on these parts of it. So that's why the DevOps engineer roles are coming day. Kubernetes, yeah, Kubernetes is covered totally. A major part of Kubernetes is covered in the course, so you will get a lot of experience on Kubernetes. We have labs as well, hands-on labs, quizzes, project. All of that is covered on Kubernetes. How much programming experience is required? Which language must be known for switching to DevOps? So personally, I would say not much, but you should be able to read the code. You should be able to read how the code is working and how those things are working. If you are not even able to read the code, that is quite a drawback, I would say. But yeah, writing bash scripts, again, for DevOps engineer, you would be writing bash scripts. So bash scripts are again some sort of language, or not bash, in Python, Golang, bash, these three you would be needing to write scripts over it, because obviously as a DevOps engineer you need to automate things, and automation comes through a language. That can be Python, that can be Go language, that can be bash scripting. So all of those things. How much programming experience is required? Okay, that's covered. Is it possible to manage your course with 9 to 5 p.m. hectic job regarding course requirements? Yeah, the course is on Saturdays. Basically, I myself have a job and this is on part time that I do on weekends. So Saturday 10 to 6, we have a course. We have break in between as well. And yeah, there are assignments, but the assignments and those things are totally uh, are basically the hands-on part that you, if you want to learn, that depends on you. Personally, I give assignments on each sort of the topic so that you have a hands-on part, and we also have labs that we cover during the class. So the hands-on part is quite much. And yeah, I have seen a lot of people cover it in the past. As I said, that 6 batches have already passed, and I think so more than 150 students would have, or 100 students would have basically cleared the course and completed it. Coming to Q, yes, how much program? Can you please define data ops in relation with that DevOps? So again, data ops is similar to DevOps, but in that DevOps basically means to handle the software application and release it to production. What data ops means is to handle the data part. For example, you are getting data from a source, then you have to run batch processing on it, then you have to push that into a data warehouse, then all of those things. So these are all data ops related to data. Part of it. DevOps means to deploy the software through that. Please share URL where you can mark complete detail of your course and schedule. I think so that Dice will share in the chat. Zainab can share that.
Sure, we'll be sharing that in a bit.
Sure, thank you. I'm already in DevOps Data Science and ML course. This batch is starting from 11th September, the next Saturday. So you can see the details from the DICE website. When is DICE starting on campus classes? On campus classes, I'm not sure about that because of the situation currently. But yeah, currently we are doing online classes. Not sure about when we will start based on the situations. Okay, now coming to the demo part. I will be basically, I have a simple application, a single page application with 2 environments, dev and prod. There is a third environment as well, test environment, but that is not working, and that is deliberately set in that way. Basically, that is not working, and this is I want to show you that the basically alerting part that I mentioned. So these are the alerts that my application went down this test.k8.kahootali.com. I have deployed it and it's not working. So I automatically got an alert of it. I am getting an alert from my Kubernetes cluster that the application is not working. Now, if I go and fix it, so I will start getting. So basically what I have done is I have mentioned a wrong image name over here. Just let me confirm this, that is the same tag or not. So yeah, v1.2.17. So I am mentioning this, save and close. This is a Lens IDE through which you can edit your Kubernetes cluster or basically see your Kubernetes cluster that I'm using over here. So this is my Go language deployment. Now it will start running, and these alerts will start going out like this. I will start getting green alerts, and the monitor is up, and it will tell me that how long was it down for. So as soon as I get that, I will show that. So now coming to the application part. So this is my application. Let me share the URL for it. So this is the test. Now it's working. Previously it was down. Now it's working. This is the dev part of it. This was test, dev, and prod. This is my dev environment. This is the home page. This shows basically my name and my designation. Then schedule, this shows that the 7th batch will start on 11th September, and this is similarly the production of it. Now what I will do is I will add in the schedule. Basically in the schedule, I will be adding one line on top of it. Sorry, this was the line that's already added, the DevOps batch 7. And now I will be adding another line on top of it. That means that the DevOps seminar is live and the attendees are awesome. So I will add this in my code. So I will add this. I will make a PR, add seminar, add, sorry, it should have been webinar, but add webinar details. So now I am committing it. I will push that to my branch. Now this is my feature branch. And now I will create a PR out of it. Add webinar details. And you can see that what has been changed in this, only this line has been changed. So now what will happen is now a CICD pipeline will start running. So over here, you can see that this is a GitHub action that started running as soon as I committed my code 12 seconds ago. And now you can see that it is building and my code, then it will build the Docker image for it, and it will push the Docker image and deploy it on the Kubernetes cluster. So, and these are the GitHub Actions CI/CD pipelines that are over the CI means the PR part. Basically, I created a PR and it started running, and it will deploy it onto the dev environment. So this is the CI part. These are all the steps that I have mentioned: initialize pipeline, echo output, log into Docker Hub, build and push Docker image, comment on the PR. If it's successful, it will comment this. If it's a failure, it will tell this. Then it will deploy it onto my Kubernetes cluster, and it will notify on Slack. So also over here, if we see, my monitor is up now, and all of my alerts have turned to green. So this is how you basically manage the monitoring part. So it's telling me that my monitor was down for 1 hour and 49 minutes. So you can also implement these sort of monitoring tools that will tell you, this is the Slack workspace, DevOps Pakistan. You can add me, and if you want, I can add you over here. Here we share the job openings as well for our previous alumni and all of that. So there are different job openings that we share, and these are for the different batches that have already been conducted. So, and now you can see that it's a successful GitHub action. So my GitHub action, it ran and it gave a notify Slack option. So basically it run and it gave a success over here. So if my GitHub actions fails, if my CI part ever fails, I will get a notification like this. Yeah, like this, that my GitHub action was failed and the workflow CD was failed, which repo, which action, which author. So you can easily add your developers to this channel, for example, and show them that, okay, so you can see that your pipeline has failed. So you need to look into it and see why it failed and what issue did it give. So now if I see over here, now my dev part is updated. If I refresh this page, so you will see that the DevOps seminar is live and the attendees are awesome. So basically, this is the change that was reflected in my code and which is now deployed onto the dev environment. Still, the production is same. If you see the change, that change is not in production yet. That change is in the dev environment. Now what happens is that you can have your testers, manual testers, or automation testing that will run on this dev environment. For example, you have a QA tester in your team. He will test your application. He will check whether all of it is working right or not, there is an issue or not. He will test this change. So this change is now deployed in a dev environment. The image is built and pushed and deployed over there. Now what I will do is I will merge that PR. Again, you can see that these are the previous students who have created PRs as well on the repo. So this is one repo that we use in the class as well. So, and all the students, they get the feel of creating a PR and basically contributing on a open source sort of a project. So again, as soon as the build started running, it commented that GitHub Actions has started building this code, check status at this. And in the end, it mentioned that the image is available for testing. So if I want to test it locally, I can do that as well. Or over here, I have also deployed it onto the dev environment. Now I will merge the PR onto the main branch. And now the pipeline for the main branch will start running. So over here, you can see this was the pipeline that ran when I opened a pull request, and this one is the pipeline that ran when there was a commit on the master branch. And you can see that again the pipeline is running. It will again build my code. So if I again go over here, you can see it will build the, okay, let me show you the previous action that has completed, because you can see the details over there. It set up Go, it build my code. My code is in Go language, so it build my code, initialize the pipeline. These are the steps required for building the Docker image. So it logged into Docker Hub using my credentials in a secret way, so no one of you can easily see my credentials. It's all in a secure way. It built my Docker image and pushed it to Docker Hub. It commented on the PR that we saw initially, and then it deployed it on my productions, on my server, on my cluster over here, and it notified on Slack. So this was the notification that came through this part. And let's see, when once the master also finishes, I will get the same notification on Slack. Hopefully it will pass. So this is how all of it's working. And also let's see the, now it's deploying, deployment is done. Again, now it's notified me of the on the Slack. So now workflow is CD. Previously workflow was CI. The event name was pull request, and now the event name is push. So it pushed to my master branch, and this basically action ran, and it gave basically worked. And now my production will be updated. So for example, if I go over here and I check my pods, so you can see that this pod was updated 27 seconds ago. This was updated 4 minutes ago. This is my Kubernetes cluster. So now my production is also updated. If I refresh the page, so you can see that change is now reflecting into prod as well. So this is the CICD part. This was CI. We basically deployed that change onto the dev environment. We tested the change. We verified the change. Everything is fine or not. Then we basically changed that or basically pushed that change onto the production environment, and we can, the actual developers or the actual consumers can view that as well. So this is some Prometheus through which I mentioned the monitoring part. So it is basically scraping data from some of the tools, and this is Grafana, where we are visualizing those tools. So for example, this is my Go language application ingress, this URL, and it's telling me that there were 71 requests, 71.8 requests almost in the last 15 minutes, and all of them are 100% success. So no failure as of yet. So you can have a detailed view. You can check on the status codes, that what status codes were sent, 200, 308, how many requests were made, what is the latency for each request, what is the new connections that are opened, what is the latency again. So these are some sort of different data points that we can see of our application. Now coming to how the CPU and data is and memory is being used. So that through here we can also see that these are my, this is my 2-node cluster basically. One is the master node and one is the worker node. So 2-node cluster. So I have 2 nodes over here, 1 and 2. So I can see the CPU usage of my nodes. I can see the CPU usage per application, how many applications and what is the CPU usage for it at the moment, what is the memory usage at the moment. So each of it that can be done, and these are all the alerts. So basically these are all the alerts that are not active at the moment, because obviously there is no issue in the cluster. But as soon as it got active, it sent over here. You can see the Prometheus event cube deployment replicas mismatch. So if I see over here, this is the alert that was firing at that moment. But currently, no, it is not firing because everything is healthy in my cluster. So these are some basically CI/CD, how application gets updated. This is how that's viewed. If the application goes down, you will get a notification like this. If there is an issue in the cluster, you can have alerts based on this, that CPU usage is up or CPU usage is down or whatever. So, and there are different dashboards for it, a lot of dashboards for basically your cluster. So you can see the CPU utilization, memory utilization, network utilization, and the disk space. So this is basic demo of how the applications run through GitHub Actions as a CI/CD tool and deploy on the Kubernetes environment. Again, this was a basic example. There are a lot of different examples as well. There's GitOps as well. Currently, I have used the most simplest way of just using the kubectl command line over here, kubectl set image for the demo, so to keep it simpler. So yeah, that's it. If you have any questions, what is that? How much programming experience is required? Again, the programming experience, I would prefer, or I would basically recommend to you guys to have some sort of a programming experience, because uh, either start learning Python a bit, start learning Bash scripting a bit, because that's many people say that you don't need programming experience, but that's not actually correct. Because as a DevOps engineer, you would be facing a lot of code. You would be facing the code. If you are not comfortable with code, or basically seeing even the code, that's an issue. You must be familiar with at least coding. I'm not saying be an expert in any of it, but try to learn how to code and learn the basics of. You can use Python, you can use uh, Java or anything. If I'm backend or front end developer, then why we should switch new field? Can't we incorporate DevOps into our field, and how it will be beneficial for full stack devs? Okay, again, a good question. That I am a backend engineer or front end engineer for these many years. So, how can I incorporate DevOps? So again, as I mentioned earlier, that the full stack devs, they are also quite in demand, and companies want people that know all of these parts as well. And full stack devs are all quite in demand at the moment, who know front end, who know back end, and who know some sort of the deployment part as well. So if you have an extra knowledge of how the deployments work, it can really boost your profile, because many companies nowadays ask for people who know these parts as well, even if they are not that much expert in this, but they are familiar with it. Because obviously, when you are a developer, you would be going through all of this. You would be going through Kubernetes cluster, that is my application up or not. Only the DevOps will not be looking into this. The developers will also be looking into this. The developer should know how to read this GitHub action output, for example, Jenkins or GitHub actions, whatever. So that's one way of handling this. And also, if you see job descriptions of developers, even there is many times I have personally seen that knowledge of Kubernetes or containers is preferred. If you have that skill, you are preferred in a lot of jobs. But obviously, yeah, DevOps, being a purely a DevOps engineer, it will not help you that much if you are a backend engineer for 4 years, because obviously you would be shifting your domain to a new field. But yeah, if you learn DevOps by remaining in your current field, you can have a vast opportunity of jobs out there. Please use Urdu as well in course for better understanding. Yeah, the language for the course is Urdu. This is a webinar basically for the whole wide audience. So we use English for it, but mostly we use Urdu in the course. I am from Microsoft Stack, so can you please mention how much of Azure we would be covering, and if some concepts apply in Azure and some we need other tools? Okay, so basically we don't cover the cloud part of it. We don't cover the cloud part. We remain cloud independent, because there might be one participant who is using Azure in his workspace, the other would be using AWS, the other would be using Google. So we try to remain cloud independent so that everyone can benefit from it. We cannot cover each cloud separately in this course, because obviously the DevOps tools are quite much, we can't cover the cloud parts of it. I think so DICE has some other courses on clouds. If you want to have basically understanding of clouds, you can look over there. But in this course, we do not cover cloud. We use cloud only for this deployments and deploying the cluster that I do. The trainees do not know. I basically create a Kubernetes cluster. The members, they work on it. They have a hands-on task on it. So we use that. I am a .NET dev. Do you cover Microsoft DevOps stack? They provide Azure Insights for monitoring and Azure Cloud. Again, the questions is same that we do not cover the cloud part of it. Everything is cloud independent. We use Jenkins. We use GitHub Actions a bit. Again, GitHub Actions, that is one thing that I have started adopting recently because the trends are changing and people are shifting to GitHub Actions. uh, we do not cover the cloud part, the Azure Insights and monitoring. We do not cover that. The detailed course contents, again, you guys can see in the link provided above by Zenab. You can go through each week's detailed contents. Uh, we do not cover those parts. And if I even open over here, let me share that with each of you so that no questions or ambiguities remain. So if we check the outline, this is the week one where we cover what is DevOps, what is these things, but then Git, what is Git, how to incorporate Git, and the best practices of using Git. Many times I have seen that even developers with 10 years of experience, they have been using Git for 10 years, but somehow they don't know the basics. So we try to cover each and every aspect of that. Then comes GitHub and Docker, how to create a pull request, forking, how to contribute to an open source repository. Then comes Docker containers. What is Docker? What is container? Installing Docker, persistent storage, volumes, logs. Then images and Docker Compose. What are images? How is image different from a container? Those parts. Then Docker Compose. Then containerizing. We containerize a Java application, a Go language application, a Python application, a Node application. We write Docker files for each of those, and we go through with each of those and the best practices of writing Docker images. So previously in our previous batch, we mentioned some best practices of writing Docker images. These are live, basically feedbacks from my students. So we mentioned some, basically we covered some views of how to optimize the Docker image. And the same question was asked from one of my students in his interview with a Spain company, within basically company outside Pakistan for a remote hiring. Same questions was asked from him, and he basically aced that interview. So uh, we cover all of those things that are applied in the industry, because I myself have been a part of industry for more than 5 to 6 years now. I have worked with international teams as well. I previously led a team that was Swedish, and we provided DevOps as a service to our Swedish clients. So I have the experience with all of those things. Week 5 is Jenkins. Jenkins is again a CI/CD tool. We cover Jenkins as well as we cover GitHub Actions a bit. Then is Ansible, Kubernetes, introduction to Kubernetes, all of the Kubernetes stuff, and then Helm and project. Basically, there is a detailed project that covers almost all of this we cover in that project. So, and if you want feedback, you can check the feedback over there as well, and also you can check my LinkedIn. Many of my students have given basically feedbacks over here, so you can check that as well. If these are some of my students, you can ask them about how it went with them. So or you can add me on LinkedIn and ask any questions. Also, I will recommend you to join this Slack channel where we are building a community where we share the job openings and those stuff as well. Okay, have you used Kubernetes in some product member, and if you have learned, have you used? I have used Kubernetes for 5 years. I have used Kubernetes for most of my life as in industry. I am a CKAD. I am a certified Kubernetes application developer. I am going to plan on CKA the next month as well. So my personal hands-on on Kubernetes is quite much. I have written a blog on Kubernetes, which has more than almost 100K views and 1.7K claps on that. So I am a public speaker as well. I have spoken on a lot of Kubernetes platforms. I've given 10 boot camps on Kubernetes. So I have a lot of experience on Kubernetes. So you can be assured of that, that I have hands-on experience on Kubernetes. Does the workshop will include from scratch concepts to actual implementation from basic, like using K8s and managing complex? Yeah, we start from scratch. Basically, this is a beginner to intermediate sort of a course. We cover all of that from beginner to Kubernetes, basically advanced, beginner to intermediate level, all of the tools that we are mentioning over here. So, and we give you the view, basically the way also that how can you move forward. Even most of my students are in interaction with me. Even now they ask me, what should we do now? How should we basically move forward with our career? So that is also one thing. And yeah, other than that, is there any question? So yeah, we have 4 minutes. If there is any question I've missed, or also like, yeah, I think so. I have covered all the questions that were in the. Okay, there are two other questions. I got your point, and you're good. I'm curious because Azure CICD configuration using YAML, and you also mentioned YAML config. So I hope concepts apply there as well. Yeah, YAML is sort of a language. Again, YAML is a language. YAML is a scripting language, as a configuration, not a scripting. Sorry, I'm misspelled that. Is a configurational language. It is used in Kubernetes as well. It is used in GitHub Actions as well. It is used in Docker Compose as well. For Ansible as well. So we cover Ansible, YAML as well a bit. We basically try to share the major concepts of YAML. So we cover all of that. लंच मिलेगा हाँ घर में ले लो जाके. So thank you so much for your answer. Okay then, I think so there are no more questions at the moment. If you have any questions, you can ask me through LinkedIn, or you can join the Slack channel. Basically, we are trying to create a community out of it. Again, you can join me or search my LinkedIn as well. I'm quite active on LinkedIn. You can connect with me, and we can have a conversation over there as well after the session ends. So I think so that's it, Zainab. Can we end
Thank you so much,
this?
Mr. Reddy. Yeah, thank you so much for joining us today and conducting such an amazingly interesting session. You guys know that you can email us for the recording or any queries regarding our trainings at info@diceanalytics.pk. Take care, everyone. Allah Hafiz.